Today we see computation of latitude and departure. When we do traversing by prismatic compass, we'll plot the traverse directly on the sheet by using length of the line and the bearing of the line or the included angle between the line. But when we traverse it by the theodolite, we convert each line into latitude and departure. That is, we convert it into the coordinates. So, what is latitude and departure? We'll see. Latitude here, I have written a definition. What is latitude? Latitude is a distance of a line, distance of any line measured parallel to the north-south direction. That is called latitude. And distance of any line measured parallel to east-west direction. It is known as departure. Here we'll see what is latitude and departure. Suppose there is a line AB. There is a line AB whose length is L and it is making angle theta with the north. So what is its latitude? As per definition, distance of a line measured parallel to north-south direction. This is north, then this is the south. If this is the east, then this is the west, north-south and east-west. Okay. So, according to definition, what is latitude? Distance measured parallel to the north-south direction. This is line AB. Here you can see the line AB. Now, distance parallel north-south means if we draw the projection of this line, or we draw the components of this line, it is like this will give the distance of this line, this point B from point A. This is the horizontal distance, that is distance along the east of point B, and this is give the distance along north of the point B. Okay, suppose this is Y and this is X. So this distance, this Y distance, is nothing but the distance of this line AB parallel to the northeast direction, north-south direction. This is north-south direction, and this is the line AB, and this is the distance of a line AB parallel to the north-south direction. That is therefore Y, and this is the distance of line AB parallel to east-west direction. This is east-west direction, and this is line AB. So this distance is projection of line AB, or we can say the distance of line AB parallel to the east-west direction. Okay, so if this angle is theta, we have discussed this earlier, we'll repeat it once more. Then this angle is also theta. Okay, then what is the relation between this Y and this L? If we consider this triangle, then this line is adjacent line. So here we can write cos theta. Cos theta is equal to adjacent side upon hypotenuse. This is hypotenuse, line AB. So it will get it Y by L. Therefore, if we calculate Y, it is L cos theta. And this Y is nothing but the distance of this line parallel to this north-south direction. So we can say that latitude of this line AB, latitude is equal to L cos theta. Now we will see the departure. What is departure? It is a distance measured parallel to east-west direction. This is the east-west direction, and distance of line this AB line parallel to east-west direction is this X. So here by trigonometry we will get this is x is the opposite side to this angle, so we can write it down as a sin theta is equal to opposite side, that is x by this hypotenuse L. So here we will get x equal to L sin theta, and this x is nothing but this distance of line AB parallel to the east-west direction. So we can call it as a departure. So departure of this line AB is equal to L sin theta. So latitude of this line, that is distance parallel to the north-south direction, is L cos theta, and departure of this line, that is distance parallel to the this east-west direction, is L sin theta. Okay, so keep in the mind, what is latitude? Latitude is the L cos theta, and departure, latitude is L cos theta and departure is L sin theta. What is latitude? Latitude is L cos theta and departure is the L sin theta for this line AB. Now, if we say in this quadrant it is L cos theta and latitude is L cos theta and departure is in the L sin theta, is it true in for other quadrants? We'll check it. Suppose if this line AB is in this quadrant, southwest quadrant, so and this is the reduced bearing of this line theta, so we'll see what is the latitude and departure of this line. Here, this is suppose this is our line AB. So what? So now, what is the latitude? What is the latitude? It is the distance of a line, this distance of this line measured parallel to this north-south direction. Okay, so north-south direction distance measure of this line. This will become our latitude. Okay, now what is the departure of this line? It is the distance measured parallel to the this east-west direction, that is this distance. Okay, so we'll see if the length of this line is L. So what will be this distance? See, this is the again opposite side, and if we say this is the x again, so this is the opposite side, and this angle is theta. So here sin theta, we'll get sin theta is equal to x by L. Okay, therefore x is equal to L sin theta. Okay, x is equal to L sin theta, and this x is nothing but the distance of this line parallel to this distance of this line AB, that is x is the distance of this line parallel to this east-west direction, so it became departure. So here also departure is equal to L sin theta. Now again this distance, that is length of this line parallel to the north-south direction, length of this line parallel to the north-south direction. Suppose this is the y. Okay, suppose this is the y, then this is equal to this distance is equal to this distance. If this is the y, then this will also become y. Okay, so now here in this triangle, this is the adjacent side. So what we'll get? We'll get cos theta is equal to y by L, that is adjacent side upon opposite side. Therefore here cos theta, we'll get cos theta is equal to y by L. Therefore y is equal to L cos theta, and this y is nothing but the distance of this line parallel to this north-south direction. That is, this is nothing but the latitude of the line. Therefore latitude of this line is latitude L is equal to L cos theta. So Here we can see if the line is in this quadrant, then latitude was L cos theta, departure is L sin theta. Let it be in this quadrant. What is its latitude is L cos theta and departure is the L sin theta. So let it be in the any quadrant. So what our definition is, latitude of a line is distance measured parallel to the north-south direction, and it will always be equal to latitude will always equal to L cos theta, and it is the distance parallel to this north-south direction. And departure is always L sin theta. Departure is always L sin theta. Okay, and this is always parallel to the east-west direction. Okay, so here we will see. Now if here you have seen that if line is in this quadrant, also it is latitude is L sin theta, L cos theta. If here line is in this quadrant, then also latitude is L cos theta, departure is L cos theta, sorry, departure is the L sin theta. So how to differentiate the quadrant? Means if it is in the, if its bearing is north theta east, or if the line is in this direction with the quadrantal bearing south theta west. So how to differentiate? So to differentiate it is, we have made this, if we consider this north direction as in a simple graph, here use here we generally see in the our graph papers we plotted, this is the positive direction and this is the negative x direction. Okay, and this is positive y direction and this is the negative y direction. Okay, and this is the positive x and this is the negative x. Here also we have used east is positive and north is positive. If your line means latitude is along east, then if departure is along east, then departure is positive, and if latitude is along north, then it is positive. If latitude is along south, if your latitude is along south, then it will be have the negative value, and if it is along the west, then also it has the negative value. So here what we are saying here, north and east are positive and south and west are negative. Okay, north and east are positive and south and west is negative. Also here latitude, here we have seen latitude along north. There are some more concept such as northing, southing, southing. Here what is northing? Northing is nothing but latitude of a line along north. Northing is nothing but the latitude of a line along north is called northing. Okay, and southing is latitude of line along south. If towards south, if the latitude of a line, see, if your line is in this quadrant, its latitude will be along this direction. See, if your line is in the first quadrant, then what is the latitude? Latitude is the distance parallel to this north-south direction. So here your latitude is parallel to the north or towards the north. If your line is in northeast quadrant, then your latitude is towards north or along north. If latitude of a line is towards north, then it is called as northing. And here you can see this is the line, another line. This is in southwest direction. Its latitude is also along. It is also the latitude of this line is that is the distance of a line measured parallel to the north south direction. Here, this is the distance of this line, but it is toward the south, so it is called as southing. Got it? If latitude is along or it is towards north, then it is called as northing. And if latitude, this is also latitude, if latitude is towards south, then it is called as southing. And in the similar way, if departure is along east, then it is called as easting. Easting means latitude, departure towards east. If departure is towards east, then it is called as easting. And if departure is towards west, then it is called as westing. Okay. Here see, this is the line, and departure of this line is distance parallel to the east-west direction. This is the departure of this line. Okay, but it is towards east, so it is easting. So this is called as easting. And here you can see this line. If we see the departure of this line, that is distance of a line along east-west direction is this distance, and this is towards west, so it is called as westing. Okay, so now latitude towards along north is called northing, latitude along south is called southing, departure towards east is called easting, and departure towards west is called as westing. Okay, so here we will see if what will be the different signs based on different signs of latitude and departure based on the quadrant in which that line lies. Okay, here you can see this table. This is the table. If this is north, south, east, west. Okay, here suppose our line AB, there is one line AB, whose length is L, and its what will be the reduced bearing of this line? It will be this is north, this is theta, east. Okay, so this is line AB. I have made the table here. The line length, reduced bearing, and what is the latitude departure of this line. Here, this is the line AB whose length is L and whose reduced bearing is north, theta, east. North, theta, east. Okay, you know what is reduced bearing. Bearing of a line measured from what? North or south towards east or west. Okay, so this is the bearing of this line measured from north or south, which is nearer. Here north is nearer, so we have measured bearing of this line from the north towards east. Okay, so bearing, quadrantal bearing of this line AB is north, theta, east. Keep in the mind, while always here we need to convert the bearing of a line into the reduced bearing. Okay, or quadrantal bearing. Here, what is the bearing of this line? This is a line AB, this is reduced bearing north, theta, east. So, what is the latitude of this line? What will be the latitude of this line? Just now we have seen, let it be in the any quadrant. what will be the latitude of line? That is latitude of line L is equal to L cos theta, and what is the departure of a line? D is equal to L sin theta. Okay, so here same we can write the latitude of a line is L cos theta and departure of a line is L sin theta. Okay, but here what we need? We need to give the sign. Here this is our line AB and it is in the quadrant northeast. So what is the latitude of this line? It will be the L cos theta, and what is the departure? L sin theta. The difference is only in the sign. Okay, see, this is towards latitude is towards north, so our latitude will be the positive, that is L cos theta, and departure is along east, that is departure is, what is departure? L sin theta, but it is towards east, so our departure will be positive. Okay, suppose if we consider another line in this quadrant, that is southeast quadrant, then what is the bearing of this line? Quadrantal bearing of line south theta east. Okay, so here what is the latitude of this line BC? Suppose this is line our BC and this is line BC with length L, and its reduced bearing is, what is the reduced bearing of this line? South theta east. South theta east. Okay, so what will be the latitude of this line? South means minus, this is our, means latitude is along north south, but it is towards south, so its sign will be the minus. South minus, east plus, north plus, and west minus. Don't write like this, just for understanding I have written this. Okay, so our line is in this quadrant southeast, so latitude is towards south, so it will have the sign minus, so latitude will be the L cos, head of this line BC will be the minus L cos theta, and what will be the departure? It is the distance parallel to the east west, but it is towards east, so east, that is, then departure will be the, departure of this line is the positive sign, that is plus L sin theta. Write down this table. Okay, then suppose there is a line, another line, that is this is line CD. If this line is, this is line CD, and having reduced bearing of this line is south theta west. Okay, south theta west. So this line is in south west quadrant. Its latitude is along south, and its departure is along west. So what will the sign of latitude departure? Yes, both are minus. So latitude of this line CD is, this is line CD with length L, and its quadrantal bearing is south theta west. So this will be the, what is the latitude of this line? It will be the minus L cos theta, and departure is minus L sin theta. Okay, now if our line is DA, this is DA, if our line is DA, it is in the now northwest quadrant, and what will the reduced bearing of this line? This will be the theta, that is north theta west. So what will the latitude of this line? Latitude of this line is this, that is parallel to the north, so it will be the positive. Okay, here what is the bearing of this line DA? It is the north theta west, okay, and latitude is along north, so what is the sign? It is L plus L cos theta. Okay, and if And what is the departure of this line? It is towards the west. It is towards the west, so its sign is minus. That is minus L sin theta. Here simply see, if it is north, latitude is positive. If it is south, latitude is negative. If here it is south, latitude is negative. If it is north, latitude is positive. Okay. Now see, here it is east, so departure is positive. East, departure is positive. It is west, so departure is negative. West, departure is negative. Okay, so departure along west is negative and departure along east is positive. Latitude along north is positive and latitude along south is negative.